Hello friends, I'm Anand Panjbhai at Engineers Classes and we're going to start with long transmission line now. See, we people have seen what is a short transmission line, we have seen that what is medium transmission line according to the kilometers and all. Now when you talk about a long transmission line, it is really difficult to lump all the parameters at the end, like we have studied end condenser method, or the middle or center of the transmission line, which is our nominal T network or T model of the transmission line, and we cannot even model it as pi model. Why? The reason is that when you have a huge transmission line, everywhere you are having, see, this is a long transmission line, everywhere you have inductor, capacitor, inductor, capacitor, inductor, capacitor. So ultimately, if you lump this entire, say, parameter, that is a capacitor mainly, at one end, you will not get correct answers. You will not get correct voltage and current profiles. You will not get correct regulation as well. Fine. So that's why we have to find out a different methodology in which we will model a transmission line where voltage and the current both, we know that voltage and current both over here and here, they are different. Every point, if we see as the transmission line is having such lumped parameters, such inductor and capacitor connected or developed on it, fine, we can say that every point the voltage and current will be different. Every point voltage and current will be different. Voltage will be different due to this I into X voltage drop, and current will be different just because we have this shunting element. Is it clear? So we can say that every point we are having different voltages and current. So we can say that my voltage and my current, they are function of X. Fine, that is the length of the transmission line. Is it clear to all of you? Fine. So we can say that we have a huge long transmission line and we are dividing that transmission line in infinite small elements, and I am considering one of the smallest element over here, which is dx. Sorry, इतना बड़ा dx होता है, साला लिखने के लिए इतना बड़ा है. Otherwise, this is a tiny little distance that we have, where obviously some impedance is there and some admittance is there. Is it clear to all of you? पता चला सबको? Clear? Fine. So we can say that this transmission line is having so many inductors, capacitors, capacitors. We are considering a very small element, and we must have understood it so well till now that voltage is a function of length and current is also the function of length. And in our case, length is x. And considering x is equal to 0 over here, which is our receiving end, so here the voltage is VR and current is IR, and x is equal to L, which is my sending end, the voltage is Vs and current is Is. So here voltage and current both are function of x, that we people have understood. Now here I am considering Z. Basically I have inductance only, but resistor is also there, right? When you talk about a conductor, there is a resistor. Fine. And here also you have conductance and susceptance. So you have admittance over here. Fine. So we can say that y, choto y, it is admittance per kilometer, mho per kilometer. Is it clear? Fine. Okay. And z is impedance per kilometer, which is ohms per kilometer. So this is z into dx. So I have calculated the value of impedance in dx region. 1 kilometer का z जितना है impedance, पता चला कि नहीं पता चला? 1 kilometer का impedance z जितना है. So we can say that it could be meter as well, right? It could be meter. I guess it is in meter only. Right? It is in meter. I guess it is in meter. Yes. So it is per meter, and right, per meter, ohms per meter. I don't know whether it is kilometer or meter. Kilometer था? किलोमीटर ही होगा. हाँ, 200 किलोमीटर. हाँ, सही है, सही. It is per kilometer. It is per kilometer. It is per kilometer, right? So we can say that, see, 1 किलोमीटर का z जितना है, तो 0.1 किलोमीटर का कितना होगा? 0.1 multiplied by z. Fine. So dx is my 0.1 किलोमीटर. समझ पड़ रहा है कि नहीं समझ पड़ रहा है? Fine. और dx is not 0.1 kilometer. dx is tiny little value, right? dx is tiny little value. It's change in x. That's it. And when you say it is dx, dx is what? It is something which is tending to 0, and that's why it is dx. Is it clear? पता चल रहा है कि नहीं पता चल रहा है? So we can say that the portion that I have over here dx, the impedance is given by z into dx. The total impedance of dx region is a clear, fine, and total impedance is also given by y into dx. कोई डाउट इसके अंदर? पक्का पता चला? पक्का पता चला? Great. So we have got let at distance x from receiving end, let at distance x from receiving end, voltage is Vx, voltage is Vx, and current is Ix. दिखा कि नहीं दिखा? फाइन. अच्छा, यहाँ पे जो भी वोल्टेज होगा वो ज्यादा होना चाहिए. क्यों? क्योंकि इतना ड्रॉप हो जाएगा और बाद में मुझे Vx वोल्टेज मिलेगा. And this is going to happen everywhere. Do you understand? Every segment it is going to happen, right? That's why I'm saying that the voltage profile is altogether different throughout the transmission line. Clear? Fine. Okay. So we can say that after dx section shown in figure, the voltage and current will be as follows: Vx plus dVx and Ix plus dIx. क्योंकि यहाँ पे Ix जा रहा है तो dIx जितना करंट यहाँ पे जाएगा. So I can say that dIx is going here. So this is my dIx current. So Ix plus dX is this current which is coming from here. Fine. Okay. यहाँ पे Vx मिल रहा है तो यहाँ पे प्लस माइनस कितना ड्रॉप होगा? dVx का ड्रॉप होगा. प्लस माइनस dVx का ड्रॉप होगा. So we can say that it is Vx plus dVx, right? इतना वोल्टेज x में dVx का ड्रॉप हो गया and we have got Ix current over here. So I can say that dIx is like this. It is preferred to write down over here. So you can see that. So Ix and dIx, the addition is here, and this is so I'll write down. This is plus minus dVx. क्लियर हुआ कि नहीं हुआ? फाइन. सो Vx में इतना ऐड होगा तो मुझे Vx plus dVx वोल्टेज मिलेगा, राइट? सो आई कैन से दैट व्हाट इज माय dVx? What is my dVx? I have derived it differently in previous years. Like यहाँ पे वोल्टेज डिफरेंस कितना हुआ? Vx plus dVx minus Vx बराबर. So that is my voltage difference, right? It gives me dVx. I mean I into ZDX is nothing but the voltage difference that I have over here. पता चल रहा है कि नहीं पता चल रहा है? That is how I have derived in previous years. अभी हम लोग नागराज कोठारी को फॉलो कर रहे हैं तो उसमें जिस तरह से दिया है we can say that dVx इसमें आने वाला voltage is what? Current multiplied by ZDX. Current multiplied by ZDX. So Ix multiplied by ZDX. Sir, how can we consider whether it is Ix or Ix plus IDX? I mean dIx. Fine. So guys, always remember that when we are dealing with this is a tiny little segment. There is no change. तो अगर मुझे वोल्टेज का चेंज ढूंढना है तो मैं करंट को फॉर्म रखूंगा कि मेरा करंट Ix जा रहा है वहां पे. क्लियर हुआ? और यहाँ पे दिस इज वेयर द प्रॉब्लम कम्स. यू नो ये Ix कैसे आया? सो दैट्स व्हाई माय प्रीवियस मेथड वाज वे बेटर. फाइन. जिसमें वो ऑटोमेटिकली आ ही जाता था ऐसा. क्लियर? फाइन. पर ठीक है, अभी लेट अस कंसीडर दिस. आपको पता चला व्हाई आई हैव कंसीडर्ड Ix plus dIx is a very small, I mean there is a very small change into these two. तो जब मैं change in voltage find कर रहा हूँ तो मैं Ix को Ix ही लेने वाला हूँ. पता चला कि नहीं पता चला? और जब मैं यहाँ पे change of current find करूँगा तब मैं इसको Vx ही लूँगा. इसके अक्रॉस कितना वोल्टेज है? Vx वोल्टेज है. Clear? I am going to see it from this end. That's it. Fine. क्योंकि Vx और Vx plus dVx में फर्क ही नहीं है. Clear हुआ? Fine. That is where the calculus comes into picture. समझ पड़ा कि नहीं समझ पड़ा? Okay, so Vx into I'm sure Nandish is not going to understand this, so he's going to ask me a question. किसी को डाउट है इसके अंदर? Done. Vx और Nandish, Vx plus dVx is the same. Fine. When you see this video, if you'll find difficulty over here, you know, see understand. Vx जो वोल्टेज है वो ऑलमोस्ट सेम है इसके जितना. So if I want to find out dIx over here, you have to consider Vx voltage. Do you understand this? Fine. I'm sure you are getting it now. Fine. And this is Ix current. तो यहाँ पे जो करंट जा रहा है, I'm considering Ix only because I want to find out the difference in the voltage. जो छोटा सा डिफरेंस है ना वोल्टेज में, वो डिफरेंस डिफाइन करना है. सो आई कैन से छोटा सा डिफरेंस इन वोल्टेज दैट इज इक्वल टू Ix into ZDX. फाइन. एंड so we have got dVx is equal to Ix into ZDX. Fine. dx को नीचे ले आओ तो we have got dVx by dx is equal to ZIx. Equation number 1. Similarly, let's find out dIx. इसमें आने वाला करंट कितना? voltage multiplied by admittance. So voltage multiplied by admittance is giving me dix. So we have got dix by dx is equal to by vx. Okay. Now take differentiation of equation number 1. इसका वापस differentiation करो. So d by dx of dvx by dx is equal to d by dx of zix. So we have got d square vx by dx square. D square vx by dx square is equal to z. बाहर निकल गया dix by dx. Oh, dix by dx is equal to yx. So I can put it over here. From 2, put the value of dix by dx. We get d square vx by dx square is equal to z into yvx. Is it clear? So we have got, it is a linear differential equation and its solution is given by. See, there are solutions. You can see the differential equation. You know, you have studied it to maths 3 that the solution for such differential equation is this only. Right? You have also studied it into electromagnetics as well. Fine. उसमें भी हमने ये चीज पढ़ी है. Okay. So Vx is equal to C1 e raised to gamma x plus C2 e raised to minus gamma x, where gamma is propagation constant. Gamma is propagation constant and C1 C2 are arbitrary constants that we can calculate by putting the boundary conditions. So we have got first equation over here. Fine. So Vx is equal to C1 e raised to gamma x plus C2 e raised to minus gamma x. This equation is nothing but the solution of a equation, differential equation. We can, we have solved it into maths. हमें पता है ऐसा लिखा तो ये लिखने का, कुछ अलग टाइप का लिखा तो कुछ अलग लिखने का. Fine. Okay. That you have already studied into mathematics. Is it clear to all of you? All of you? Fine. Done.